For decades, Mercury, the smallest planet in our solar system, was regarded as nothing more than a barren, lifeless rock, a scorched world trapped in the sun's blistering embrace. Forgotten amidst the grandeur of Jupiter, Saturn, and even Mars, Mercury was a planet that seemed to have no secrets left to reveal. But then, something happened that stunned the scientific community and captivated the public. NASA's James Webb Space Telescope, humanity's most powerful eye in the cosmos, suddenly shut down. Why? What could it have discovered that sent shockwaves across the world, forcing swift and secretive action from the US government? What Webb uncovered about Mercury would change everything we thought we knew about the planet. With its advanced infrared imaging capabilities, Webb has revealed that Mercury is not the lifeless world we once believed. Beneath its scorched surface, it harbors something astonishing: diamonds. Yes, diamonds? These precious stones, formed under immense pressure and intense heat, are scattered across Mercury's surface, glittering like fragments of a celestial treasure chest. This discovery is unlike anything we've ever seen before, and it shatters the notion that Mercury, with its violent geological past, marked by volcanic eruptions and asteroid impacts, was a barren wasteland devoid of any value or wonder. Instead, these diamonds tell a much deeper, more intriguing story. They suggest that Mercury underwent a profound transformation, preserving evidence of its violent history in a way no other planet has. But that's just the beginning. Webb's instruments didn't stop at Mercury's sun-baked surface. They peered into the planet's darkest corners, the polar craters, regions so cold and shrouded in perpetual shadow that the sun's scorching heat cannot reach them. And what they found there is nothing short of mind-boggling: water ice. Water ice on Mercury. This is a discovery that defies logic. In the face of the sun's intense radiation, one would assume that water would have long since evaporated from Mercury's surface. But in these shadowed craters, the ice remains intact, hidden from the sun's fury, preserved in a frozen oasis. Even more extraordinary is what the Webb telescope found within that ice: organic compounds. These complex carbon-based molecules, the very building blocks of life, are eerily similar to those that sparked life here on Earth. Could these molecules have formed naturally within Mercury's harsh environment, or were they brought here by ancient comets or asteroids? And if Mercury, with its extreme conditions, can harbor water ice and organic compounds, what does that say about the potential for life in the most unlikely corners of the universe? James Webb's revelations have forced scientists to reimagine the very nature of habitability. Could Mercury, once thought to be geologically dead, actually harbor the essential ingredients for life: complex chemical reactions, organic compounds, and water? These discoveries challenge everything we thought we knew about what it takes for a planet to support life. Mercury, far from being a dead rock, is emerging as a vibrant, dynamic world full of hidden secrets that could redefine our understanding of life in the cosmos. Part 2: Mercury's massive core and magnetic mystery. Mercury has long been overshadowed by its larger and more famous neighbors. Yet beneath its surface, the planet hides a feature so remarkable it challenges everything we thought we knew about planetary formation. Mercury's core makes up a staggering 85% of its total volume, by far the largest core-to-volume ratio of any planet in the solar system. To put that in perspective, Earth's core only comprises about 15% of its total volume. What could explain such an extraordinarily large core? This mystery has left scientists pondering the fate of the planet in its earliest years. One prevailing theory suggests that Mercury was once much larger, but a catastrophic collision with another celestial body early in the solar system's history stripped away much of its outer layers. This violent impact could have left behind the dense, iron-rich core that we see today, as well as a thin mantle just 420 kilometers thick, a fraction of the thickness of Earth's mantle. This collision might also explain Mercury's surprisingly high density and its unique composition, unlike any other rocky planet in the solar system. But Mercury's mysteries don't stop at its massive core. The planet also possesses a magnetic field, a feature that makes it unique among rocky worlds. While planets like Venus and Mars lack global magnetic fields, Mercury's magnetic field is present, albeit weaker than Earth's. What's even more perplexing is the asymmetry of Mercury's magnetic field. Measurements show that it's stronger in the northern hemisphere than in the southern, an anomaly that has puzzled scientists for years. What could be driving this strange magnetic field? Unlike Earth, where the field is generated by the movement of molten iron in the outer core, Mercury's magnetic field seems to result from a combination of factors. Researchers believe that Mercury's core consists of a partially molten outer layer surrounding a solid inner core. The planet's slow rotation, combined with its proximity to the Sun, creates a unique set of conditions that results in a magnetic field unlike any other. And the Sun itself plays a significant role, as its immense tidal forces affect the movement of Mercury's molten core, further complicating how its magnetic field is generated. Mercury's magnetic field, though only 1% as strong as Earth's, serves an essential function. It acts as a shield against the relentless solar wind. This protective barrier prevents the solar wind from stripping away Mercury's fragile exosphere, allowing the planet to retain its thin atmosphere. Without this magnetic shield, Mercury would be exposed to even more extreme conditions, making it even more inhospitable. The presence of this magnetic field raises intriguing questions. Could it hold the key to understanding Mercury's violent past, including its interactions with other celestial bodies? Does the planet's unique core suggest a history of processes vastly different from Earth and the other rocky planets? The discovery of Mercury's magnetic field challenges our assumptions about what makes a planet dynamic and active. It forces us to rethink everything we know about planetary evolution. Part 3: Ice and the potential for life on Mercury. In a solar system where extremes are the norm, Mercury stands as a paradox. As the closest planet to the Sun, its surface temperatures soar high enough to melt lead. And yet, the James Webb Space Telescope has uncovered something utterly unexpected: pockets of water ice, preserved in the planet's polar craters. These craters are uniquely positioned to stay cold enough, shielded from the Sun's heat, preserving the ice indefinitely. It's a discovery that defies all logic. These ice deposits, hidden in the planet's shadowed regions, could hold the key to understanding life's resilience in extreme environments. But what's even more extraordinary is the presence of organic compounds within the ice. These complex molecules, strikingly similar to those found on Earth, are the building blocks of life. Could Mercury have once harbored the conditions necessary for life, or could it still? Mercury's extreme environment may seem inhospitable, but the discovery of water ice and organic compounds challenges our assumptions about where life can exist. Could life, in some form, have once existed in these icy havens? Or could the planet still harbor secrets about life in forms we cannot yet imagine? The discovery also has profound implications for the rest of the solar system. If water and organic molecules can coexist on Mercury, one of the harshest planets in our solar system, what does that mean for the potential for life on other planets or moons with similar conditions, like Europa or Enceladus? Mercury's ice could offer clues about how to find life on other celestial bodies, expanding the range of places we look for signs of habitability. Part 4: Volcanic Activity and the Mysterious Geological History of Mercury. For centuries, scientists believed that Mercury was a geologically dead planet, its surface a silent, frozen relic of a time long past. But recent discoveries, including those from the James Webb Space Telescope, have turned that assumption upside down. Evidence of ancient volcanic activity suggests that Mercury was once a dynamic, ever-changing world. The northern and southern volcanic plains on Mercury, vast flatlands that formed billions of years ago, are thought to have been created by massive lava flows that erupted from the planet's interior. These eruptions would have reshaped vast portions of the surface, leaving behind smooth, featureless regions. But volcanic plains are not the only clue to Mercury's fiery past. The planet's surface is also marked by mysterious features called hollows, shallow, irregular depressions that are unlike anything seen on other planets. These features are believed to be the result of volatile compounds near the surface being vaporized by the sun's intense heat. As these materials evaporate, they leave behind depressions, suggesting that Mercury is not entirely dormant. In fact, recent data suggests that Mercury's volcanic activity may not be entirely in the past. Chemical signatures found on the planet's surface indicate that smaller-scale volcanic processes may still be at work. The discovery of these volcanic compounds, sulfur, potassium, and sodium, provides further evidence of Mercury's dynamic geological history. Part 5, The Sun's Influence and Mercury's Strange Orbit. Mercury's orbit is one of the most unique in the Solar System. While it takes just 88 Earth days to complete one orbit around the Sun, a single day on Mercury, defined as the time it takes to rotate once on its axis, lasts a staggering 176 Earth days. This strange spin-orbit resonance, where Mercury rotates 3 times for every 2 orbits, is a result of the Sun's immense gravitational influence, which has slowed Mercury's rotation over billions of years. The result is a world with days twice as long as its year, creating a surreal experience on this strange and mysterious planet. This odd orbital pattern is just one of many features that makes Mercury one of the most fascinating